In our project SO, we have received an assignment to explain the physics behind gases in English. And to do that, we will use a balloon as an analogy for how gases behave. So, gases. What happens to a balloon in its various flight stages? First of all, we have to ask ourselves, what is a gas? Now, a gas is actually just one of the distinct forms the phases of matter takes on. And there are three forms: solid like ice, metal or wood, liquid like water, and the last one is a gas, just like the air we breathe. To go from one state to another, you need energy in the form of heat. When you add heat to the ice, the molecules starts to move faster. Thus it melts and turns to a liquid, which is water. Now, if you go further and add more energy, the molecules moves even faster and the water turns into a gas, which is the steam that comes from trains. So, this is not quite true. There's actually one more state. It's called plasma, which looks like this.
So this is my plasma ball. This is plasma inside here.
Now, in order to understand how gases behave, you have to learn how the ideal gas equation works. So how does the formula for the ideal gas equation look like? It looks like this. P times V equals N times R times T, and they all stands for something. P stands for pressure, and the formula is F over A, which is force over area. We can use an elephant foot as a good example to explain the formula. If we look at the foot, which is being drawn right now, we can see there's a force being applied towards the ground, and the total area is the elephant foot, not to mistake. Now, if we increase the area by putting something bigger beneath the foot, the pressure will decrease, since the force and the area is inverse proportional. But if we reduce the area, the opposite will happen. The pressure increases. So what does V stands for? V stands for volume, which is area times height. As you see on the video, area is length times width, and in theory it is just two-dimensional. But if we add a height h, we get a cube, which is three-dimensional. It's kind of like the things and stuff we see around us, the world, the earth. Or actually, it is the world we live in. So what does N stands for? It stands for mole, and it is a unit that some smart people around the world define to be 6.022 times 10 to the power of 23. It is just like other units. A pair is 2, a dozen is 12, and it is of everything. It could be of an atom or it could be of a molecule. R is a constant, and the constant is defined by what kind of unit you want in the end of your answer. Is it 1 bar or is it 1 atmospheric? If you would like to know more, you can look up all the different constants on the internet. T stands for temperature. The temperature can be measured in Celsius, but with time, scientists figure out that it is not convenient, and they started to use Kelvin instead. This is because the 0 point of Celsius is in physics terms not actually zero. The absolute zero in Celsius is actually minus 273. But in Kelvin, absolute zero is zero. Thus, it makes it easier to work with. Now, how does the law apply to a balloon? To answer this question, we can take a look on 3 different stages of what we can call a balloon trip, and look on what happens in every stage by rewriting the equation to explain what is going on. In stage 1, we rewrite the equation to Avogadro's law which is N over V, equals the constant P over R times T. The law says if N increases, V increases too. If the amount of molecules increases, the volume increases proportional. And that is exactly what we see is going on with this balloon. The next stage is Boyle's law, which states that P times V equals the constant N times R times T. This means if the volume increases, the inside pressure of the balloon has to decrease. Now with this balloon you see above, the opposite is happening. This actually happens when the balloon reaches very high altitude. The air gets thinner and the overall pressure from outside decreases. When that happens, the volume of the balloon increases too, and the pressure inside decreases. The inside and outside pressure has to be in equilibrium whatsoever. The last stage is Charles' law, which states that V over T equals the constant N times R over P. This means if the volume increases, the temperature inside the balloon has to drop, since the molecules is being spread out. Thus, there is less energy per given volume. Now Frederick would like to set up a practical example where he will show how to use the equation mathematically.
So how can you use the ideal gas equation? Let's look at a typical assignment. A man buys a balloon of which he knows the temperature is 20 degrees Celsius, the pressure is 101,300 pascals, and the balloon has 100 moles, and he knows the gas constant. He wants to find the volume. The ideal gas equation can be rewritten to isolate the volume. Then we insert the numbers instead of the symbols, so we have the volume equals 100 moles times the gas constant times 293 Kelvin divided by 101,300 pascals, which equals 2.4 cubic meters.
So to finish this video off, we will leave you with these beautiful words. So whenever you stand with the balloon in your hands and you ask yourself, what happens if I let go? Well, now you know.